Today we are going to study about Newton's law of universal gravitation. Up to now we know that around Earth, if there is some mass, then it feels a force of attraction towards the Earth, and this force is given by the gravitational force Fg. And if the mass of the other object is m, then this force is given by mg. But this gravitational force of attraction, is universal for all the masses. And also in this particular situation, m is getting attracted by Earth, and Earth is also attracted towards the smaller mass by the same amount of force. So this force is universal to all the masses. So let us find out a relation for force for any two arbitrary masses. Let us say we're talking about two masses m1 and m2, and m1 is applying an attractive force on m2, which is given by F12 vector, and m2 is applying a force on m1 towards m2, and it will be given by F21 vector. Also, the distance between them, the unit vector from 1 to 2 will be given by R12 unit vector, and the unit vector from 2 to 1 will be given by R21 unit vector. So these unit vectors, they are opposite to each other, and they are also opposite to forces. You see that R12 unit vector is directed towards right, while F12 unit vector is directed towards left. So if F12 is in this direction, R12 is in this direction. So they are opposite to each other. So if we have to write a relation between F12 and R12, so F12 vector will be equal to, we should have a negative here, and R12 unit vector, because they are opposite to each other and they have the same direction except that they are opposite to each other. So if F12 is towards the left, R12 is towards the right, and it is given by capital G, mass of one object, mass of the other object, divided by the distance between them, which is R12 magnitude squared. Okay, and this R12 and R21, they will have the same magnitude, so we can also write it as R squared. The direction of R is different, but R magnitude will be same, so they both have a magnitude of R. What I mean is that R12 vector magnitude and R21 vector magnitude, they have the same magnitude R. So even here we are writing R12 squared, we can also write it as divided by R squared. Similarly, we can also write an expression for F21 vector, which is the force on 2 because of 1 will be given by minus g, product of the masses divided by the distance between them squared, and unit vector. So when we try to understand this expression, this negative sign, it means that F12 and R12, they are opposite to each other. Okay, and it also means that the gravitational force is always attractive. So whenever you have a system which has two masses, they will always have an attractive force towards each other. And this depends on these masses. If you have a large mass, it will have a higher force, and if you have a smaller mass, it will have a very small amount of force. So all these objects, like they have some mass, so they will have some force of attraction towards them, but it is too little because they have a very little mass. And it also depends upon r. So if something is at an infinite distance away, it will not experience any force, because then the force will turn out to be 0. So now we can also write an expression for Earth mass system on the same lines. Let us say that, like here we have taken two masses m1 and m2. Now let us say that we take masses. The first mass is Earth, and the second mass is some mass small m. But before telling you about this, let me also tell you what is g. G is called a universal gravitational constant. And it has a value of 6.67 into 10 raised to the power minus 11. And we can find out the unit from here. It will be Newton meter square upon kilogram square. So it will be Newton meter square upon kilogram squared. Also, the magnitude of both these forces, they will be equal. So F12 vector magnitude will be equal to F21 vector magnitude. And we can say that both of them, they will be equal to any force Fg. So if we have to write the magnitude of a force of this, we just have to take a magnitude of this, when you take a magnitude of this, then negative will turn out to be positive, and R21 is a unit vector, so its magnitude will be equal to 1. So this will be positive, this will be 1. So what will be left with is G m1 m2 upon r square. So this will be the gravitational force between any two masses which are separated by a distance r. So now let us use all of this definition in a Earth mass system. So let us say that you have Earth with a mass me, and there's another mass small m which is kept near Earth. So small m will experience a force towards Earth, and also Earth will experience a force towards small m. So this force will be Fg. Similarly, me will also experience a force towards small m, which will also be Fg. Okay. And the distance between them, let us say that the distance between them is from me to m. So let us say it is r. So if we are taking vectors, so let us say these are vectors. So let us say it is r vector. But you know what a vector is? Vector has a magnitude and it has a unit vector. So it means that this unit vector, r unit vector, is from Earth to small m. So if we have to write now Fg for this system, let's use this expression. So gravitational force will be given by universal gravitational constant, mass of Earth, the other mass small m, divided by the distance between the two squared. So it will be r squared. We can also write it in vector notation, and we can say that Fg squared will be equal to minus g mass of Earth, mass of small m divided by r squared and r unit vector. This is because when we are talking with respect to Earth, the force is in this direction, unit vector will be in this direction, so they are opposite to each other. Let's not write this one so that it doesn't confuse you, although this is true for small m also. But in this case we are talking about r unit vector, so that becomes easier to understand that r unit vector and Fg vector, they are opposite to each other, and therefore we can write this expression. And we also know that it is equal to g into m, because we know that f is equal to mg, and m is the mass kept near Earth. While in vector notation, so from here we can say that Fg upon m will give you g magnitude. But from here we can say that Fg vector upon small m will give you minus g capital Me upon r squared into r unit vector. So it means that this is g vector. So Fg vector upon small m is given by g vector. So from here we can conclude that g vector is minus g mass of Earth divided by r square into r unit vector. This is also relevant because you see that the gravitational acceleration is towards the Earth, while r unit vector is from Earth to the mass. So r unit vector and g vector, they are opposite to each other. So we can get a negative sign here. And if we have to find out the magnitude of small g, it will be capital G Me upon r square, because negative will turn out to be positive and unit vector has a magnitude of 1. So it will turn out to be 1 and therefore g will be this. And if we put the values and this r, now we also have to understand what this r is. R is the distance from the center of Earth to the center of this mass. But the radius of Earth is given by Re. While this is at what height this object is, let us say it is h. And usually Earth, the radius of Earth is usually very larger than small h. So in reality, maybe in some problems, maybe you'll have to use it, that Gme will be r squared could be replaced by Re plus h squared. But if Re is very larger than h, then G could be written as G mass of Earth upon radius of the Earth squared. And if you put the value of mass of Earth, G, and radius of Earth, you will get ultimately G to be equal to 9.8 meter per second squared. Now here we have found a relation for G. And what is the meaning of this G actually? And what is the meaning of unit vectors? Because we've never used unit vector we've never used an expression like this for gravitational acceleration. Okay. So now from this relation, G vector is actually called the gravitational field. Okay, so around Earth there will be a field around Earth, and that field will be always towards the Earth. So this will be G vector. It means a field. Field means some invisible force around a mass due to which another mass feels an attraction. So this G is given by minus G Me upon r square into r unit vector. This is quite comparable to charges. Like if you know that there is a positive charge Q, it has a field around it, which is electric field. In a similar manner, Earth or any mass has a field around it which is towards that particular mass, and so it is quite comparable. So G vector is also called gravitational field.